Hello, everyone. It's been really humbling to hear from several of you about some of the challenges that you face. I personally come from various telecom companies before working for Amazon for the past 8 years. And at Amazon, I've been pretty passionate about operations, both internally and with our customers, and particularly with this telecom segment. So I'm here to talk a little bit about how we approach our infrastructure and our servers, the technologies that are possible, but then more on how our customers are using automation and machine learning to create self-healing networks and also take care of automation. Okay, so first, we have millions of customers, active customers every month, and for that we need a large expanding infrastructure. So the way that we've expanded is into what we call regions, and regions are combinations of availability zones. So availability zones are more there for the purpose of fault isolation. These are mostly combinations of data centers that are isolated over a certain distance to meet with compliance. They have mesh of networks between them that are redundant and have the relevant subscription ratios that you would expect. So in the sense that we will make sure that traffic doesn't get dropped across these availability zones, in between the availability zones, and also across regions. And so getting onto the cross-regional portion of this, we actually have our own networks across our points of presence. We have over 160 of them between our regions. And we extend this connectivity to our customers' data centers, because we recognize that there are very important use cases and workloads that need to work in hybrid environments. And so with one of our services that's called Direct Connect, we actually do offer an SLA for that connectivity. So getting beyond the network and getting beyond our peering, I also want to tell you about our servers, right? Our infrastructure. You would consider our NFVI, Vim. And so how do we manage this? What components does it have? So when you look at core servers, they're called EC2 instances, right? So these are running on top of our hardware, on top of our specialized network. And these have combinations of attached storage, attached metadata for configuration, and a whole bunch of different software from different vendors, OS vendors, different software from people called out Palo Alto, people called out SDN, WAN optimization. And so a lot of these different vendors have their AMIs, or what we call Amazon Machine Images, available on EC2. We also have a large ecosystem of Docker containers, of course, that you could pull in and deploy on as well. So how do we actually approach our hardware, right? So many of you manage your own hardware. And the way we have really been able to give full performance to the user is by separating the actual server, the machine, versus any function that we carry out. So we have this Nitro system, which is separate hardware components that take care of the network offloading, the security and management, the performance, even the storage I/O processing. So all of that happens on these separate pieces of hardware that we acquired a company called Annapurna a few years ago, and that's what takes care of it. And you get your server. And the benefit of that is you get a lot of performance. So as an example, with our C5N instance types, and this is the direction that we continue to go in the future, and we're going to innovate more in this space, is with these C5N instances, you can get 100 Gbps dedicated networking across these instances. You also have the ability to go to millions of PPS, kind of more similar to what you would expect from your own environments and virtualized environments. Lower latency. And a lot of the capabilities, I get a lot of questions from telecom vendors, a lot of telecom customers about well, will this work, will that work? And so what I find is that in today's world, almost all of it is possible, right? So as far as CPU pinning, OVS, DPDK, a lot of the capabilities that you need for the performance for your customers, for your VNFs, a lot of that is possible now. It is truly possible now. I won't say that was always possible, but with these sets of technologies, it does become very doable. So just moving a little further. And this technology has also allowed us to have our partners run on us. So VMware was called a few times in terms of a virtualization, go-to place. And so the VMware Cloud in AWS works seamlessly, the same as it does on premises. It is very scalable, so the SDDCs from VMware seamlessly work on AWS, and you come with the same feature set. So you have VMware ESXi, the NSX, the same stuff that you're used to, works the same way. So especially it becomes important when you're talking about common orchestration and management or OSS systems, right? So if you want a simple and similar way to manage and orchestrate your resources, these kind of capabilities become important. And because we have offloaded all of the AWS functions or the functions that a cloud provider would need to handle, we actually offer direct bare metal servers. So if you don't want to use our specialized hypervisor, and we have a KVM optimized hypervisor called a Nitro hypervisor at this time. If you want to use your own, if you want to use OpenStack, all of that you can do on bare metal if you wanted to. And we do this because what we recognize is there's complexity, right? Many people called it out with multiple VNF vendors, different sets of requirements for different workloads. There are special characteristics that you need to account for. And so we offer bare metal instances to customers for various reasons, like you need to have your own custom hypervisor so that you don't have to test your application against some other hypervisor, and also for the purpose of licensing. That becomes a pretty common use case with bare metal. We also recognized that there is a requirement for certain workloads to have very low latency, to have very large bandwidth for compliance reasons to stay in a specific place. And so we also pre-announced at the end of last year, AWS Outposts, which is essentially the AWS infrastructure coming into your data center. So this essentially becomes extensions of AWS regions. You can keep the critical workloads and the important things that need to stay on premises. And then whatever you feel would be done in lower cost, you'd hyperscale in the AWS cloud, you can transfer that through various mechanisms, through our Direct Connect service, which you can have a lot of high bandwidth transfer from. We also have we have a truck we can ship out to you, like Snowmobile and Snowball, as we call it, that can also copy petabytes of data into the AWS cloud if you needed to. But if your workload just needs to simply live in servers, in your edges, in your far edges, in your back offices, right? That's what AWS Outposts is for. We've been investing in containers for some time. Operationally, it's something that some of our teams in Amazon also use, and so we have various services to make it really easy. So today, actually, AWS Fargate is one of our most popular services. Why? Because all that's needed is the container task, and we take care of all of the heavy lifting. So for our customers, we make sure the containers scale up and down, as long as the logic in them is horizontally scalable, of course. They scale up and down, the virtual machines underneath them stay up and down, the load balancers scale accordingly, the network scales accordingly. All of that is fully managed within Fargate. Now, for people who need more control, we also have Amazon ECS that allows you to have Docker containers that are managed with our orchestration system and scheduling. And then we also have EKS, where you can bring your own K8 into AWS, or you could have it fully managed. And then lastly, of course, you could bring it directly into EC2. And I give you all these options. And so we in AWS, I know we talk a lot about our features and about our services. It's because we find that a lot of our customers demand different options depending on what their requirements are, depending on what their workloads are, depending on what their interoperable I/O requirements are as well. So now I want to talk to you a little bit about self-healing. Right? This is something in AWS that we've been investing for a long time. Self-healing our own infrastructure, detecting when there are issues, quickly replacing things so there's minimal impact on our customers. Right? We have this notion that failures will occur, but you design for them the best as you possibly can. And then every time there's a failure, it's an excellent opportunity to learn from that failure and get those learnings back in. Yeah, it ends up being, you could say, these problem analysis, incident management, it's an important process, but it's also a little bit of a manual process. So it's really ripe for machine learning in the realm of self-learning, of self-healing, of making sure that your infrastructure is resilient to failures that you failed before, so that you can predict when something is going to happen and scale ahead of it. Many of you are working on this as well, and so I just want to tell you what we in AWS have as tools for you to use. Over time, we've scaled out our auto-scaling service, which allows you to horizontally scale servers or containers. And we recently also announced our native predictive scaling, so it's available to everyone at this point. And tell you a little bit about how it works. What we do is we forecast, and based on forecasting seasonal trends, not just like trends that happened the past day, past week, even seasonal trends, we start predicting when your next capacity requirements are going to be, or when we've seen certain failures happen as well. And you can obviously set max amounts of capacity you want to allow over here, because depending on maybe you had a massive Super Bowl event or something huge that was going on, and in that Super Bowl event, your capacity went up way high, and you want to make sure that for some reason it doesn't go up that high again for cost or for other reasons. You have that capability as well. So this is just showing you, how we are doing some forecasting. And so there are many ways to approach forecasting the different algorithms, right? One could go with, let's just look at anomaly detection when what was reality doesn't match what the forecast is. We'll just use exponential smoothing or some of those similar algorithms to do it. So we take a few combination of these to approach forecasting. In fact, now we even have a service in preview for you to use, which is called Amazon Forecast. Which you can also just plug in. So you don't have to use it for the purpose of self-healing. You could use it for different purposes as well. Now on to orchestration analytics. I had a few of you actually talk about various parts of your stack where orchestration is present, where there are pain points, where things are going to be automated. Just for getting a little bit of context into what happens in AWS for these various layers, we have the NFVO and NFVM actually living in a few AWS services. One is AWS CloudFormation. So this is infrastructure as code service that is not just for runtime. It's for what you called day two in terms of continuous operations. We also have systems manager that goes into the operating system or into the application to do what you need to do, whole parameter secrets, and a whole bunch of manageability things that you need to handle, along with CloudWatch being the monitoring, logging, and events bus for your actions that need to be automated as well. At the bottom, I have the NFVI components. We already went through a gambit of virtual machines and containers and all of those and connectivity. But for storage, there are also options that expand across NFS or NFS compliant storages, object-based storages, different types of data modeling and data storage options. So that was just for the purpose of mapping. Now, we have some customers who actually use AWS for the purpose of capacity augmentation, fault tolerance, and global outreach. In fact, it's one of the larger value propositions. And so here what I have is just this VNF, the series of VNF workloads. It's a VPC workload that is going across various continents, right? So depending on where the traffic needs to go, there are various ways to make sure that it gets orchestrated, comes up, and then the users are routed to those areas. So in the case of private LTE, someone called out private LTE a little bit earlier, it's possible, depending on your end user's requirements, you could actually fail over via DNS, right? I know with a lot of carriers, DNS is not necessarily good enough. DNS takes a certain time for propagation. And so we also have a service that we launched called Global Accelerator that actually just has one global IP with a backup IP, and that uses Anycast and BGP and a lot of similar techniques that you use to make sure that you can have the routing to the right destination, depending on your criteria, whether it's failure, whether it's latency, or other things. Just as an example, we also have OSM version 5 running on EC2. This is just the GUI that you're used to, and at the bottom, it's just one of the instances that launches the VNF from there with version 5. That's just an illustrative example, and I want to reuse that over here. So we also do take DevOps seriously in AWS. It's a little bit important for us to make sure that our customers have CI/CDs for the agility that they need for their businesses, right? A lot of the value proposition of using AWS is so that you get agility, and I know it's something that's very important in telco environments as well. Getting VNF vendors onboarded faster, realizing failures sooner, getting things replaced, bringing up new things, new products, new services, getting your customers enabled. And so we have various tools that we use, and what's more important, though, is that there's this ecosystem of and this culture of automation with each one of these pieces. So, similarly, we looked at OSM, right? So, you can actually have a CloudFormation template, which is, you can think about it like Heat. And by the way, OpenStack Heat is fully compliant with CloudFormation, so you can have all of those pieces integrated in one place if you like. But this is just an example of an CloudFormation template that is just used to launch all the various pieces that you need to get OSM running on AWS, at least for the basic purpose.
What is OSM?
OSM is open source mono. Earlier, Francisco Javier spoke about it. Okay. Oh no, it's just something we've been. Okay, fantastic. So getting into data insight orchestration. So this is analytics. We have various services that can ingest data in various forms, transform it to the ETL parts of it, and then put it into different forms of data storage. We have a data warehousing solution called Redshift. AWS is used a lot for big data workloads, for Hadoop, Yarn, Spark. And then what we realized is that, great, some people love to use those. Some people have the time to develop all of that. But in the end, if you just need to get data or insights from a large set of unstructured or structured data, you need that tooling to be available to you. So Athena is an example of a tool that we have for ad hoc queries. QuickSight is an example of a tool that we have for driving analytical insights from large sets of data as well. So the example that I'm just giving here is that using some of these analytics, you can actually pipe into an automation pipeline here. So what I have is these analytical insights coming from Redshift or QuickSight or various other services feeding into our CloudWatch events. And CloudWatch events can then trigger actions. Lambda, shown over here, is actually our code as a service. So this can execute code in microservices at any scale that you prefer. And in this situation, we have our analytical insights telling us that we need to actually change our capacity. We need to either add more instances or remove an instance or replace an instance. And so then what we're doing is that we're updating our DNS records and using auto-scaling to update the instance capacity for your VNFs in that use case. So this can be used for self-healing. This could be used for augmentation, whatever you need it for. We have, just as a reference, NTT Docomo running a large amount of their analytical workloads on Amazon Redshift. They found 10x better performance. They actually have one of the largest columnar warehouses in the world for this purpose. Can we do better? And I think the answer is yes, we can do better. So the word AI, as was correctly called out, it's like this all-encompassing, very futuristic word, but what's real today is deep learning, right? So deep learning is actually very mature, especially with certain frameworks, and we want to enable all of that. So in AWS, we try to be Earth's most customer-centric company, and we want to enable as many workloads as possible. We realize and recognize that there are different types of users, and that's why we have a whole stack here, and I want to go a little bit deeper into. So we have some experts actually in the room on deep learning and machine learning. And if you set up your AI ML workflow, this is sort of what it looks like, right? You have so much data, right? People call out so much data in their networks. But it is actually very time consuming to scrub that data for the use case that you want to use it for. For the data labeling portion, it can be quite a lot of heavy lifting. And then after that, once you have the data, it's possible, depending on use case, there's already a wonderful framework that makes things super easy, right? Today, facial recognition, vision, even personalization, good frameworks for all that stuff. It's gotten mature. That's where deep learning has gotten really mature. But for your use cases, it's very possible that you don't actually have a mature framework. And that's where you need the experimentation. You might even need to build one. And that's a tough piece. And so there's also this minutia of model training, parameter tuning, model testing, and simulation. Great. So I created my model. I'm not really getting anything useful from it. It's telling me that it's later now, so that's an insight, which is not a very useful insight. But we take a lot of that heavy lifting away from you. So as an example, we have one of our services called Amazon SageMaker. And so what SageMaker does, this little icon over here, SageMaker. And so it's a fully managed ML service. What it does is sets up the pipelines for you, the data ingestion for you, allows you to choose from a bunch of algorithms that we know work for certain use cases, allows you to scale up and down based on how much usage your model is taking. So you don't have to worry about the pipelines. You don't have to worry about the infrastructure usage. We take care of that and cap it for you, and you can even integrate it with low-cost options if you prefer. So that's in terms of if you really want to do go deep into machine learning. In the case of certain use cases, it actually makes sense, right? You might want to do that for CDR analytics and analysis and using them to drive various business actions. But for a lot of users, they just want a specific output. Yeah, they want a service to tell them, hey, can you do this object detection for me? Can you tell me if this face actually matches this pattern? And we have a range of services for these. So on the top, over here on the top, you can see recognition video. This is all for detecting faces or objects. And then poly, which is text to voice or speech to text in both ways. And transcribe is across other mediums. Translate is for multiple languages. Comprehend is for natural language processing. Lex is for chatbots. We've also got a few more services that are not listed here for personalization, for getting insights from text. And so we also have one for forecasting. And you can expect many more. Now, even despite these managed services, what we recognize again and again is there are different type of use cases and workloads. So we've tried to make an ecosystem where multiple frameworks can just work in EC2 natively. And examples of that are actually, here's an example called Gluon, which we actually co-developed along with Microsoft, which is actually useful for a fair amount of use cases. And then a lot of these that you might recognize, like MXNet and TensorFlow. We also invested in GPU instance types and FPGA instance types for this sort of processing, because for certain use cases for both ML inference and for really crunching down and having a very useful model, GPUs become quite important. And so our P3 instances significantly reduce the amount of processing time for making these models more mature and more usable. As an example, Airbnb uses these P3 instances for getting through their experiments faster, getting through the iterations faster. In Amazon, we have been using machine learning for many, many years. We use it for personalized recommendations. If I can just ask, has anyone ever gotten a personalized recommendation from Amazon.com? All the time. OK, has anyone ever got a useful recommendation from Amazon.com? Sometimes. OK, there you go. So we're trying to get better. We're trying to learn on that. But obviously, if it was people, it would be a little bit challenging. So it's a classic machine learning problem. We also use it for our drones, for Alexa voice services, and also for Amazon Go to detect if you have taken something that you're going to purchase and what that thing was. There are challenges in ML, and these challenges do expand to telecom as well, which is that ML expertise is rare, scaling infrastructure is hard, especially doing it in a self-healing and automated way is quite hard. Data pre-processing is time-consuming, and that can cost a lot of money if you're not doing it right. I mean, we're talking about pretty large scale over here. So what we've tried to do through the services that we've gotten up there that I just quickly went through was we tried to make ML accessible to all of you, simplified pre-processing and scrubbing of that data, taking away the noise to help you get the signal, and then reducing the time and cost of these experiments through various optimization techniques. So I can talk about some of those a little bit later as well. OK, so just going a little bit further. So in our ML stack, I talked about image and video analysis. I talked about personalization. So these are just things that you interact with the REST API, and you get responses back. For areas where you actually need to create new ML models or experiment with new frameworks, or even with existing frameworks, we have SageMaker, allowing you to do this across multiple pipelines in a repeatable way. And we also have these frameworks that are getting popular. And this is the interesting thing about frameworks. What exists today might not be here next year, right? These frameworks are ever-changing. Being agile in these networks, being adaptable to new frameworks, being adaptable to new technologies is actually core to the success of our own business and of our customers' business. And so that's what we're investing in, that agility. Now, specifically on the subject of CDR data, right? Because I think many of you work with it. Oops, let's try and go back. Unfortunately, there's a little bit of an issue here with the rendering, but what we have, and so this is available right now for all of you to try, is we have a cloud formation template. So in just a few clicks, you can deploy a fully working AWS solution that allows you to ingest your CDR data. It will use various AWS services, and using that, ultimately, this will go into what we talked about with SageMaker, and you can experiment, and you can bring things to production, and then you can build with this example. So we have some training sample sets for CDR data. I'm sure you have many of your own, but this is something that you can deploy today with just a few clicks. I briefly touched on one of our services called AWS QuickSight. It's a data visualization and insights and analytical tool, and also can pipe in with events if you needed to. And given challenges of data being hidden in aggregates, it being tough to put into a tool to actually get you good insights, and the fact that you can't wait for manual BI insights to come in weeks after something has happened. We do have this solution right now. So we have a beta going on for AWS QuickSight anomaly detection specifically. So this becomes a pretty important area and important service in many different areas. But what we can do is we can analyze many different millions of metrics. So it's not just about one metric, because we recognize that anomalies in one metric is a little bit easier, right? Once again, you could do that with exponential smoothing. But millions of metrics becomes a little bit of problem scale. So it's an area that we're investing in. How that could work over here is that you have these AI-driven insights from a service like QuickSight, and you could have that same pipeline for automation that I mentioned earlier. So QuickSight says that, hey, there's an anomaly over here. We think that this is a failure. And then you could have CloudWatch events trigger our code as a service to do all the necessary actions you need to get done. So it could update your DNS entries, remove the old ones, move to another one for blue-green deployments. It could change your BGP routes if you wanted to. It could scale up and scale down your EC2 instances, or interact with your other mono layers like OSM if you wanted it to. So those are just some ideas and options available to you. What we see in telecom with regards to automation and AI ML are 4 areas. And I would love to talk to you after this if there's any other that you think that we should be investing in or that you need. One is the customer experience. So we know that proactive care is very important, right? We all care about our end customers. Being able to get them insights and answers quickly is critical. Predicting churn. Churn is such an important metric, right, for CSPs. Being able to predict in which direction it's going so that we can take actions faster before we lose customers. Doing those diving saves for large segments is important. For churn, actually, we have a full solution. So if you're interested in that, we can help you deploy that pretty quickly. And then personalization, targeted marketing. So coming into the second category, which I really focused on in this talk, which was AI and ML in network operations and automation. So by the way, I do want to say that I'm humbled again by the level of insights that you gave today. All of you saw it, and everyone. And I realized that the view that I'm giving you here is a very AWS infrastructure-centric view. And so when I'm talking about real-time monitoring and I'm talking about adaptive network management, it's really with regards to AWS infrastructure. And so we can chat more about, and we can ideate more offline about how we can adapt this in various different areas and not just this environment. Also, OPEX reduction, really critical. So we have, even for us, and for any large company like all of yourselves, detecting fraud is super critical. And this is also a very classical machine learning problem. Detecting when someone is doing something bad, it's a bad actor, that is very critical. And so that's also something for which we have some pre-made solutions in which we've helped our telecom customers with fraud detection. We'd be happy to work with you on that too, if needed. And then the last one is data monetization, right? It's the whole area of how do we get the relevant OPEX reduction, where does it make sense in terms of margins to have, to invest in more IoT, to invest in 5G and not have the waste so that it actually becomes useful. Not only that, also have the useful experiences to your end customers and the value to your end customers so that it's worth their money as well. That's all I have. Thank you. Questions? Microphone. Let's see. One's on the way.
Thank you very much for that very comprehensive talk. I'm interested in the network access for AWS, both your public cloud and your hybrid slash outboard cloud. And I'm aware of several, and let me spit them out and then perhaps you could rank them. There's a direct connect, there's the Amazon virtual private cloud, there is the public internet, there is the Equinix Cloud Exchange, and then there is the network service provider partnerships where they make the AWS point of presence as a node on their VPN. Could you please give us some perspective on the ranking of those, if not percentage, just ballpark, which are the ones that are in favor, out of favor, whatever?
So various different options to connect into the AWS.
And there may be others that I don't know, but those are the ones that I'm aware of.
Absolutely. It's a good question. There are various different options. They fit different use cases. So with actually a lot of our partners, some of them in the room, right, we have our direct peering in terms of our networks to make sure that we have giving our users connectivity. We actually are really moving towards the direct connect model. Why? Because our customers are demanding it. Direct connect is a service with which we give dedicated bandwidth. So there is a bandwidth and an availability guarantee with an SLA. So Direct Connect comes in both flavors. So there's both the real and the virtual. And so we also have many users going through VPN, either a software VPN or a hardware VPN into the AWS cloud. But then the challenge with that VPN and for that user is that they don't necessarily get bandwidth guarantees and they don't get the SLAs for availability that I mentioned. And so it's for different use cases over here. And even for providing Direct Connect, we have Direct Connect partners. It's actually some of them are in the room that also provide that connectivity into AWS while still giving the guarantees that we talked about. So you can bring the microphone, but I'll just repeat. You mentioned that at the AWS Summit, the only one that we mentioned was Virtual Private Cloud. Virtual Private Cloud is our virtual network offering, so it allows you to define security groups, routing rules, routing tables, a lot of the things that we feel many customers need in order to manage their networks. And so Virtual Private Cloud is where your resources are living. It's the network within AWS. But in order to connect into the network, you have to use Direct Connect to come in or VPN to come in. So some customers do use public internet to come into the AWS cloud as well. I mean, as far as we're concerned, security is our top priority, and we would always recommend a customer to come in through a VPN or, yeah. Thank you. Sure. Any other questions? Oh, you guys are a smart crowd. Thank you.